work on inequalities. So what do you guys think of when you think of like an inequality? Like, or maybe you think of a symbol or something like that. What do we think of with the word inequality?
Unequal.
Unequal, perfect. So an inequality means not equal to. And I'm going to write this kind of small, but not equal to. Does anybody think of any kind of like a symbol or phrase or anything with an inequality? Yeah. Great. Yes. Greater than, less than, maybe greater than or equal to, less than or equal to. And one we actually used a couple days ago with our restrictions. We're not really going to use this today, but a not equal to that we did for our restrictions, that's also an inequality. We're going to focus on the greater than, less than or equal to, greater than or equal to today. Now, whenever you have a solution to an inequality, this, if it has a solution, is gonna, I'm going to say, represents a range. So it's not just one solution usually when you work with these. It represents a range of possible values. And we're going to get into some examples like right underneath here in a second. But it's not usually just one number. If it has a solution, it's usually multiple numbers would fit the requirement. Now, we're not going to graph any of these in the coordinate plane today, but we're going to graph these on number lines today. So just a single variable inequality. We'll do two variable inequalities a little bit later in the unit. So basically what I have here in this first example, I'm hoping you guys know how to tell me how to write this lovely graph as an inequality. There you've got 4 little examples. And what I think will be new to you today is we're going to talk about how to write that in what we call interval notation. Both of these are really important, but really going forward we're going to use the interval notation a lot because that's what they're going to use in your upper level classes, your pre-calc and trig and your calculus and things like that. So we're going to start introducing interval notation to kind of move and connect that with our inequality notation. So let's look at these lovely graphs. So my first graph here, and forgive, this is not the greatest graph I've ever created, but my first number line has a solid circle at -2 and has an arrow going over the top of the number line that points to the right. Can anybody raise your hand? Could you write me, let's just use X, right? I'll just use X. Could you write me the inequality that would match that graph? What would that look like? Jonathan, what do you think? Perfect. Greater than or equal. How'd you know it was or equal to? Exactly. If the circles, I always remember it this way. If you see it, it's solid. So I'm going to see the little underline on my inequality symbol if I got a solid circle, or on an actual graph in the coordinate plane. If you got a solid line, you've got you're equal to. Now, how did you know it was greater than? To the positive, right. So if it goes to the greater than goes to the right, so whatever is bigger, like, I don't know, somebody told me this, like the open mouth of the alligator goes towards what's bigger. So this is saying the numbers are all bigger than or equal to -2. Now this, I don't know if you guys will know this or not, so I'm going to show this to you. You may have seen interval notation, but probably not. So the way interval notation works, you're just going to have 2 values in a set of grouping symbols, either a bracket or a parenthesis. So we're going to talk about that here in a second. But you want to start with the smallest possible value on the graph, and you want to end with the largest possible value on the graph. So what is the smallest possible value I could be on this graph? -2. So you're going to start with -2. Okay, now here's the way this works. If you have a solid circle, that means I can actually touch that value. What you use for your symbol here is a bracket. So it's just going to be, it's like a rectangle with one of the sides cut off is what it looks like, but it's kind of a hard corner here. That's going to indicate to you that you can touch -2. Now, you just, after that, you put a comma. So smallest possible value, then a comma. Now this is a little weird. Can anybody tell me the biggest possible value on that graph? What do you think? 3 on the picture there, but like theoretically the biggest possible value. What? infinite, so infinity. So that points to the right forever. I know my number line only goes up to 3, but if it kept going, we would go up to infinity. Now, infinity is not a specific number. Infinity is going to be, you know, I can always add one more to a number and keep going, keep going. So you can't actually touch infinity. It's not a specific value. So for that, anytime you have an infinity symbol, you use a parenthesis because I don't actually touch that number. All right, somebody help me out with my second graph. This, I should have made these a little bit bigger. So I got an open circle at 0, and I've got a line pointed to the right there. What would be an inequality for that? Rudy, what do you think? X is greater than 0. All right, now, here's the only difference. You're going to start with the smallest number. If you got an open circle, you just use a parenthesis instead of a bracket because I don't actually touch the 0. Then you use a comma, and that one is similar to the one above where it's pointed to the right forever. So the biggest possible value go all the way up to infinity. And infinity only has parentheses. They are never touching infinity because I could keep adding values to that. All right, let's check out the third graph. Now, this has a closed circle at +3, and this arrow's over the top of the number line pointed to the left. What do you think?
X is less than or equal to 3.
Perfect. Less than or equal to 3. Excellent. All right, now, can anybody tell me what is the smallest possible value this graph would go to? How do we think? Negative infinity. Okay, so just like positive infinity, I'm going to start with the smallest value, but any infinity symbol, positive or negative, is going to go with a parenthesis, because on the negative end, I could keep subtracting a number and keep getting smaller, smaller, smaller. So negative infinity, you don't actually touch a specific value. And then what is the last value I can touch here? 3. And because the circle is filled in, we just put a bracket with that for that notation. So it's saying any number from negative infinity stops at 3 would satisfy that inequality. All right, and then we have one more. This has an open circle at 1 and points to the left. How could I write that inequality?
X is less than 1.
Excellent. X is less than 1. Anybody want to try the interval notation maybe? What do you think?
Negative infinity, 2. No, 1, 0.
1, 2, 0. Which one do you think? Where's my open circle at on that number line?
It's on 1.
There you go. So we'll use 1. Okay. You gonna use a bracket or a parenthesis? There you go. I think it's like I made a big O on it, so I know why you said 0. But yeah. So just look at the graph wherever the open circle's at. Again, these are not my most perfect number lines ever, but excellent job. Is anybody having a question? Closed circle is a bracket, open circle is a parenthesis. Infinity is always a parenthesis. Lower number on the left, bigger number on the right. All right, now, these are just graphs. I'm going to actually give you an inequality kind of in a format we need to solve, and then we're going to actually graph, and I'm going to see if you can also maybe try out the interval notation today. So my first little example, I just have -10 greater than or equal to, and then on the other side I have 2 times the quantity, 3n plus 1. Does anybody know, maybe what would you do first if I was asking you to solve this inequality? Jonathan, what do you think?
I would distribute the right side.
Okay.
And do -10 is greater than or equal to 10 plus 2.
Perfect. What do you want to do next? Okay. Good. Yep. Good. Okay. Now, there you go. Now, I had somebody last period, and I do this too. You don't have to, but I just want to show you this is exactly right. Anytime I have an inequality in just one variable, I'm not flipping anything. I am switching the order that this is written in. Okay, and I would just recommend this to you just because if you have the variable on the left side, so this says -2 is greater than or equal to n, the other way you can read this is n is less than or equal to -2. I didn't do, I don't want to say I flipped anything, but I turned the entire inequality around. The little part still points toward the end. Does anybody know the reason that that's helpful to have the variable on the left? Yeah.
It shows which one is on the line.
Exactly, exactly. If you got the variable on the left, that can help you point your arrow on the graph so you don't make a mistake. Now, we do not have to do some elaborate, okay, number line. There is a blank canvas here, little arrow, don't get crazy. Just put the number that you need, like I need -2. Maybe do one number that's a little bit bigger and one number that's a little bit smaller if you want to. You really don't have to. I just want to see the number that is necessary there. So -2. If I was graphing this, would I have an open circle or closed circle at -2? Closed. If you see it, if that's underlined, if you see it, it's solid. We're going to fill that right in. That means -2 can be part of my answer. And then this is less than. See how the arrow points to the left? Less than points to the left. If your variable's on the left, you can just follow the direction that that arrow points to help you. It doesn't have to be perfect. You don't have to draw 6,000 numbers on the number line. Just kind of place it and the number you need and maybe a couple numbers around it. Can anybody raise your hand and tell me what you would write for the interval notation for that one? What do you think? Perfect. So it's saying it could go to the left forever. Any number smaller than -2. So all the way to -infinity, and we would stop at the -2. That's the biggest value we could have. Perfect. All right, who wants to try the one next to this? I've got 6 minus 5 times the quantity 2 plus x is less than 41. What do we think? What would you do first on that next one? Camry, go ahead. Good deal. So what would you write? Okay, plus -5 would be the same as... You're right. I would just do it like that. It'll make it easier. Plus -5x is exactly true, but if you have plus a negative, if you want to just write that as subtraction, it just might save you a little space. Okay, what do you want to do next? Perfect. All right, where do you want to go from there? Heck yeah. All right, so we got -5x is less than 45. What do you want to do after that? Okay. And what would you then write? You're fine, you're fine. No, you're fine. I'm just going to ask you guys. Okay, so we didn't have this happen in the last question, but we do have this happen here. So I have written right here that we divided by -5. Does anybody remember if you're working with an inequality?
You divide by negative, you gotta flip the inequality.
Exactly. So you did everything perfect, but with just as a last step, this is the little parts pointed toward the x. Since I divided by that -5, now the open part, or the big open mouth, if you will, goes towards the x. So anytime you divide by a negative, you got to flip that. Is there any other situation where you'd flip the inequality? If I divide by a negative or multiply by a negative. That doesn't always happen, but anytime you divide or multiply by a negative number, you got to flip the inequality symbol. Now, like on this previous question here, we divided both sides by 6. We got a -2 in that last question, and sometimes that'll throw people off, and they'll think if they got a negative, they were supposed to flip the sign. No, it's only if you divide or multiply by a negative. If you just subtract something or you just add something, you don't move or flip an inequality symbol there either. Now, for this lovely question, this is nice for us because We already have our variable on the left, so we can just use it to follow the arrow. So again, I am not going to draw some elaborate number line. I'm just going to put -9, and honestly, I'm fine with that, as long as you got the arrow going the right way. But if you want to put like a little bigger number, -8, a little smaller number, -10, should I have an open circle or closed circle at the -9? Open. Can't be equal to it. Which way should my arrow point? Right. Greater than goes to the right, less than goes to the left. Or if you got your variable on the left, just follow the arrow. That'll help you. What would I write for the interval notation for this one? Hunter, what do you think? Perfect. Bracket -9, that's the smallest value. And then everything to the right of that would go up to positive infinity. Excellent. Does anybody have a question? Yes. Yes, my fault. Parenthesis, because we have an open circle. That's my fault. Bracket on this one. Parenthesis on this one. Okay. Anybody else having a question? All right, now, these two are kind of weird. So these are what I would call like a special case. But they're both inequalities, kind of similar to what we just solved, but I'm going to show you guys that you can have a weird scenario happen, and that's what's going to be going on these two questions. So if I try to get all my variables on one side, I'm just going to subtract 7x from both sides of both of these inequalities, or both sides of the inequality. But what you'll notice there is I had a positive 7x on both sides. This would just cancel. What would you write on the left? If I do 7x minus 7x, what does that become? 0. You're subtracting. So, okay, if I'm dividing and doing something like that, that becomes 1. But if I'm subtracting or adding, this actually becomes 0. So I don't have a variable anymore. This is going to say 0 is greater than or equal to 14. So then you got to ask yourself, I got no variable here, so I don't have a range of solutions. What do you think about that inequality? True or false? False, right? 0 is not equal to 14, and 0 is not bigger than 14, so it doesn't fit either requirement. All right, so if it is not true, which this is not, what does that mean to you? I just wrote no true, not true. Okay, not true. What does that mean? Like in terms of my answer? No solution. Not true. No solution. There is literally no value for x that you could plug in there that would ever make that inequality true. So in that case, we would not have any kind of interval notation, and we would not have any kind of a graph because we don't have a solution. Okay, now the one next to this is going to be kind of similar but a little different. So kind of the same thing. I have a positive 2x on both sides. So if I tried to get all my x's to one side of that inequality, it's actually going to cancel out on both sides. And I'm going to have -3 is less than 2. So if all your variables cancel out, you're going to have to ask yourself, like, true or false, what do we think? True. 2 is bigger than -3, or you could say -3 is smaller than 2. Okay, so if this is true, what would I say is my solution? Does anybody know? Yeah. Infinite solutions, but I'm going to write it like this, because we're trying to say what x could be. There are infinite values. I'm going to say all real numbers. So if you want to use that symbol instead, that capital R with the double stem, that just is an abbreviation for all real numbers. And just means any number you could think of. You plug in for x would always make that equation true, or inequality true, I'm sorry. Anybody know what the graph for that would look like? If everything is a solution. It wouldn't have to say between -3 and 2. It's kind of weird. Does it, like the graph could be, if it could be any number, what would your graph look like? Yeah, it's literally just right on top. You don't have to put any numbers on here if you don't want to. It would literally just be like the entire number line. So you could just have a graph just right over the top of the number line. You wouldn't even have to label it. Would anybody want to try the interval notation for all real numbers? It has to be everything. What would you tell me the smallest possible value is? Okay. What would you tell me the biggest possible value is? There you go. That's all it is. Just parentheses on both because you can't actually touch infinity. But that interval there, negative infinity, comma infinity, parentheses around both, that tells you all real numbers. You will see that many, many, many times as we go through the course of the year when we start describing domain and range for graphs and things like that. So that means all real numbers. Okay, now at the bottom here I've got compound inequality. So we've just been doing a single inequality. We're going to do compound. I just put a little picture of each. The first picture is what we would call an AND statement, where basically you're going to be between two values. You can technically write this as two separate inequalities, but I'm going to write this as a single inequality to make it a little easier to work with. And then the one next to this is what we would call an OR statement. Two inequalities on the same graph, and you can satisfy one or the other. When you have an AND inequality, your solutions have to satisfy both. Okay. So I prefer this notation, and I would recommend you do this. I'm going to put an X in the middle. I'm running between two numbers on that number line, and the arrows always, always, always point to the left if you do this properly. So I'm going to start with the smaller value that has the circle, open circle, which is -2. And the -2 is less than the X. I promise you, if you do this correctly, and it's just a plain less than symbol because the circle's open. The arrows on a compound inequality with a variable in the middle should always point to the left. If they don't, you did something wrong. So this is saying X is bigger than -2, and then this will also point to the left, and because that 3's got a filled in circle, I'm going to say less than or equal to 3. So it's saying X is between those two values. If you do, I'm going to write this just so you can see it. This as two separate, this would be X is greater than -2, and at the same time, X is less than or equal to 3. So you can write it as two separate inequalities, but I would highly, highly encourage you, write it like this with the X in the middle because it makes it easier to work with it. Lower number on the left, bigger number on the right, and then both symbols should point to the left. So again, this is saying X is bigger than -2, but at the same time less than or equal to 3. Now, the interval for this, these are super, super quick. You're just going to use those two numbers and then base your bracket or your parenthesis on the inequality symbol. So since -2 has an open circle, it'll be like that, -2, and since 3 has a closed circle, it would have a bracket. So it's saying it would run between -2, but it can't be equal to -2, and +3, and it can be equal to +3. Now, for an OR statement, you're going to have two separate inequalities on the same graph. You can't put these together. Don't try to write them in this format. If you do, it will not be proper notation of any kind. You cannot put them together. You have to write it as two separate. So I've got one pointed to the left. So I'm going to say X is less than -4, or X, the other one is an open circle at -2 and goes to the right, greater than -2. You cannot put those together like I did here. They have to stay as two separate inequalities. And then to write the interval notation, just like I have two separate inequalities, you'd have two separate intervals. So we'd have the -4, it's going negative infinity, stopping at -4. Both of those would be parentheses because negative infinity can't have a bracket and -4 has an open circle. And then I'm just going to write OR. The second part of the graph starts up at -2 with an open circle and goes to positive infinity. So it would be -2 to infinity, both with parentheses. Is anybody having a question about the AND and OR? We're going to do one of each on the back. Okay. So, up here at the tippy top, I have an AND statement. And again, I'm telling you, it's easier to work with the variable being somewhere in the middle, which we're going to have to solve this a little bit, but you can solve it all in one step instead of doing it two separate inequalities. So if you have a format, here I have, this is going to say x, or 6x minus 1 over 5 is greater than 1, but at the same time less than or equal to 7. If you want to solve something like this, your goal is going to be to get x in the middle of that inequality alone. Does anybody have any idea if I try to get x in the middle of this alone, like what would you do first? What do you think? Exactly. Get rid of that lovely fraction. You just have to do it to all three parts. That's the only thing. It's going to work just like solving an inequality. We're just working with three different parts. All right, so multiplying by 5. So 1 times 5 is 5. And don't switch any symbols. We're not multiplying by a negative number or anything. In the middle, it's just going to drop out the fraction. And then this will stay less than or equal to, but 7 times 5 is going to change that up to be 35. What would you do next? Does anybody know? Hunter, what do you think? Add what? You just got to do it to all three parts. That's it. You can do it all at once. So we're going to have 6 less than 6x less than or equal to 36. All right, and then I got to do one more thing. What do you think? Heck yeah, divide by 6. All right, now I'm dividing by 6. It's not a negative. We're not flipping any signs over or anything like that. 6 divided by 6 is 1. In the middle, the 6's will cancel. You don't have any adding or subtracting in that fraction, so just the x left there. I don't forgive. Just plain x is greater than 1. And then 36 divided by 6 is 6. Now, when you work on this, on the number line, again, you don't have to make some elaborate, crazy number line. Just use those critical numbers. We have 1. That should be somewhere on the left of 6, which is the other number I need. I'm just going to do open circle at 1, close circle at 6, and we're going to play connect the dots. If you want to put some numbers in between on your number line, I'm fine with that. Or if you want to just leave it like that, that's perfectly fine. As long as the smaller numbers should be on the left, bigger numbers should be on the right. The interval notation for these, does anybody want to try this one? What would you write? What do you think? Perfect. Just going to use those two critical numbers that you have there. Now, don't try to put these together if you have an or statement. I literally would just do like, okay, done. We're going to solve two separate inequalities. We'll just run through this real quick. Let me subtract the 9. So I've got 3x is less than or equal to negative 12. Divide by 3. I'm dividing by positive 3, so I'm going to get a negative result here, but I don't flip a sign over or anything like that. So part of this is going to be that all x values less than or equal to negative 4. And then just totally separate problem. Just solve this little inequality. I'm going to subtract 1. Just subtracting, so we're not flipping a sign over or anything like that. So 5 minus 1 is 4. Now this one, I am dividing by negative 2. So if I divide by a negative number or multiply by a negative number, we have to remember, take that inequality symbol and flip it to go the other direction. So this is going to be x is now greater than negative 2. This is an or statement. So I got to satisfy one or the other. These should, unless it's a weird situation, these should point away from each other on the graph. So I'll just do like negative 4, negative 3, negative 2. Just write a couple numbers in there. I should have a closed circle at the negative 4, and less than goes to the left. I've got my variable on the left in both of these cases, so I can follow the arrow if I need that to help me. And then x is greater than negative 2, so that one goes to the right, but these are going to point away from each other. And when you do an or statement, we're just going to write two little bitty intervals. So negative infinity to negative 4 with a bracket, because I got a filled in circle, or the other interval would be a parenthesis, negative 2 to positive infinity. Does anybody have a question? Okay. Now, wouldn't it be a complete day without a word problem or two? So here we go at the bottom. All right, now, the first one I think you're going to find kind of similar to a couple questions we did on our first lesson, but this is going to kind of transform this into an inequality instead of an equation. So this one says your science class has 6 tests, and your goal is to average a 90, which would be an A minus or higher. So I can get an average 90 or higher, so it could be a range of numbers. And it says at the end of the semester, that's our goal. Your test grades, right now, we got a 95, 78, 97, 91, 83. What grade do you need to get on the 6th test to reach or surpass your goal? And then it says we're going to write our answer as an inequality. Okay. How would you maybe set this up? We got 5 tests. We want our average on 6 tests to be 90 or higher. What would you do with what we've got in the problem here? What do you think?
X is greater than 46, and then 95 plus 78
You're so close. Okay, well, let me leave the X there for a second. Okay, we're going to add all these tests up, right? The 95, the 78, 97, 91, 83. And eventually we're going to take 6 tests, right? So we are going to divide by 6. Let me put the X with that group, right? And I'm going to have 6 tests total. Now, I think we were just missing one tiny step. This is going to represent my average, right? So I need this to be greater than or equal to what number? 90. Okay, so we're just going to do one tiny step that I think that we missed here. I would just do one tiny step and multiply by 6 real quick. And just in the same step, let me add up those test scores real quick and see what that is. So I'm just adding up what we already have. So we have 444 plus our 6 tests, and I need that to be greater than or equal to, I'm just multiplying that 90 by 6, so it should be 540. And then I'm just going to do one quick, we're just going to subtract that 444, because that's the points that we already have. And so that means X, if I get a 96 or higher, ideally higher would be great, then our average is going to be what we want, which is a 90 or higher. Awesome. Okay, now this last one is a little bit weird. It's a compound inequality. So it says a real estate, like somebody that sells houses, agent earns a salary of just straight up $2,000 a month, plus, so I'm going to put a plus sign, 4% commission on her sales. What is that? Does anybody know what that means if you earn, I don't know if any of you guys work or anything in retail, but you know what it means for earning a commission on something? Exactly. So like if you went out and sold a $100,000 house, she gets a 4% commission. We would multiply 100,000 by 4%, and then we can figure out what her commission would be. Okay, so does anybody know? Because I got to write this as a decimal. How would you write 4% as a decimal? What do you think? 0.04. Okay, and you can make up whatever variable you want. I'm just going to use C to represent her commission. So whatever sales she makes in the real estate market here, we're going to multiply that by 0.04 and she'll get a percentage of that sale. So beyond that, it says, let's see, write and solve the compound inequality to determine the range in sales the real estate agent must make to have a monthly income. Now, there's 2 requirements here. At least $5,000, but it says because of a tax law, like maybe it would put her in a different tax bracket or something, no more than $10,000. So she's trying to save money from taxes, so she doesn't want to exceed that. So I'm going to put this between these 2. Now, anytime you have a compound inequality, we're going to fit both these requirements, be between the 5,000 and 10,000. The smaller number goes on the far left, so I'm going to put the 5,000 over there. And the bigger number goes on the far right, so I'm going to put the 10,000 over there. Now, I got to be between these 2. I swear to you, if you're doing this correctly, whenever you do a compound inequality, both the symbols should point to the left. That's saying that whatever I've got in here is in between. So it's bigger than 5,000, but at the same time less than 10,000, between these 2. Now it says at least, so she could equal the 5,000, no more than 10,000. She can also equal that, so those should both be a less than or equal to symbol. Now we're just going to do 2 steps real quick and we'll be done. So let me subtract 2,000 here. Get rid of any addition or subtraction first, and then get rid of any division or multiplication. So we got $3,000 less than or equal to 4% in commissions for her, which is less than or equal to 8,000. And then we're just going to take everybody, and it's important, you got to convert that percentage to a decimal, because if you would divide by 4, it wouldn't be quite accurate. If you're ever not sure, I'm going to write this to the side here. If you have a percent, so 4%, right? If you want to convert that to a decimal, it'd be like 4 out of 100. Like if you got a 4, hopefully you would not get a 4 out of 100 on a test or something. But if you want to do that, you can get the decimal by dividing that value by 100 if you're working with a percentage. Okay, so I'm going to take $3,000 and divide that by 0.04. So she needs to sell at least $75,000. And at most, if we divide this, $200,000. So somewhere between those two values, and she'd get the perfect salary that she wants for the month. Is anybody having a question? Okay, I'm going to stop talking for a second. Now, I'm going to put, these are the answers for what we did